In my opinion, we digitalized and we have been digitalizing manufacturing activities for a long period of time. That has led to digital transformation of manufacturing, and essentially that is enabling a lot of AI algorithms to get into manufacture, right? So that has been the sequence. So let me tell you some of the digital initiatives we have been taking for the last 40, 50, 60 years. Okay, and there are many such initiatives, right? We are not talking about one or two initiatives here. We are talking about multiple such initiatives. Okay. So the first is okay. So why did 40, 50 years ago, why did we think about digitalizing processes? We thought about digitalizing processes because then we said, well, not everybody has to do everything, right? Can we essentially centralize? Can we essentially decentralize, right? Remember 40, 50 years ago, we used to think about IE quite a lot. IE in the sense of industrial engineering quite a lot. So what was industrial engineering all about? Industrial engineering was reducing this development time, right? Earlier I told you about, right? Essentially, how does digitalization help me? Digitalization help me in shrinking the throughput time. The time when I start working on something, for example, for a manufacturing activity, right? For a manufacturing industry, for a manufacturing organization. For a manufacturing organization, what is the ultimate goal? Ultimate goal is I need to start thinking about innovative products, right? And deliver the product to the customer. That time has to be shortened in some ways. The time between me thinking about a product and me making sure that the product reaches the customer. Why is that time? Why should that time be shorter? Because if I take 5 years, 6 years, 7 years, in that 7 years, the consumer's requirement would have changed. The market would have gone somewhere else. I had a very innovative idea 7 years ago, but if I take 7 years to implement an innovative idea, the customers' preferences have changed. Consumers themselves have changed. There is a new generation of consumers now. So my product will never get sold. Therefore, in today's manufacturing industry, I cannot really be talking about time scales of that kind. 7 years, 8 years. Well, what am I thinking? 8 years? No. That time has to be shrunk. Right? What are the different phases from conceptualizing a product to making sure that the product is available to the customers? What are the different phases? First of all, the product concept has to be designed. Product concept has to be designed because I need to understand what product am I designing. Before the product design comes, the product conceptualization has to come. How do I get input data for conceptualization? I go to the market, talk to the customer. What do you want? What features would you want? What features you don't like? What kind of material would you want in the product, right? All that input is to be taken from the consumers, and then I design my innovative product. So that is essentially your marketing activity. The marketing team talks to the consumers, gets the ideas about what is the new thing that my consumers want. What is the new thing that my consumer wants? So that is conceptualization of the product. After the conceptualization, the product design starts. Right, the product designing, right? What should be the dimensions of the product? What should be the material used for the product? What should be the design of the product so that the stresses and strains are taken care of? My product doesn't fail, right? All the failure effect analysis, mode effect analysis, FMEA, all that has to be done in the product design phase. Once the product is designed, it has to be manufactured. Right, all the manufacturing, what manufacturing process am I going to use? Who are my suppliers? Where am I getting the raw material from? Right, it has to match my design. The design specs have to be met. So all those are manufacturing concerns. Once the product is manufactured, then it comes to the logistics part. Right, how do I make sure that the final product reaches the customer soon enough, fast enough? So product conceptualization stage, product design stage, product manufacturing stage, and logistics phase. Roughly speaking, you can granularize it later, but roughly speaking, these are the 4 important phases, starting from conceptualizing a product to making sure that the product reaches the customer. Right. The idea, the objective was to shrink this time, to shorten this time. How to shorten this time? One way was to decentralize the process. Why should the same person do everything? Right. remember very old times, the entire product used to be manufactured by a same team of 5 or 6 people, right? Go back and look at some of the old videos of how cars used to be manufactured before assembly line was created, right? Cars were created even before the assembly line way of manufacturing started, right? So look at those things. So essentially there was a small team which used to make the full product. So they used to talk to people, get the ideas, they used to design the product, they used to manufacture the product, they used to deliver the product, right? Idea is to decentralize. Idea is to move away from that. Because why do I want to move away from that? Because today the volumes that I'm manufacturing, I can no way have the same team doing everything. The variety of products that I'm selling in the market has tremendously increased, right? I'm not talking about only one type of car anymore, only one type of pen anymore, only one type of cell phone anymore, right? Variety is huge. I can't have a small team of same set of people doing everything. So I have to decentralize. So what is the whole thinking now? The whole thinking now is I will focus on my core competencies. Whatever I do best, I will do it. And then get people who are really best at what they are doing, right? That's how supply chains work, right? I am doing something that I can do, right? And a long time ago, I discussed about this. I am manufacturing a car. I'll get the car, but the steering wheel assembly will be done by my vendor because they are really good at making steering wheel assemblies. Somebody else is very good at manufacturing the cars. So I will focus on my core competencies, let others focus on their core competencies, and we will work together as network partners and essentially get the best product delivered. I know I can assemble the best possible car because that's my specialty. You will do a good job because you are specialist in steering wheel manufacturing, steering wheel assembly. So finally, the product that the customer gets will be of best quality because everybody has put in their best efforts, because we are experts and we are putting in our best efforts. Everybody focusing on their core competencies, and then all the network partners working efficiently will also reduce the development time, because then the product designers will focus only on the designing part. The manufacturing team will only focus on the manufacturing part, right? That has been the requirements of the manufacturing industry. So decentralization. And all that was possible through digitalization, which is why we started looking at digitalization as a very important step towards achieving all these requirements. Right. So how did we achieve that? We achieved that in inventory control. We have been optimizing inventory since 1960s, right? The automation, right? The automation of inventory decisions started happening because we sophisticated our mathematical decisions, automation, right? And soon digitalization started happening because, not only we have mathematics telling us when to order, how much to order, but now we have real-time data. We have real-time data saying that, oh, my truck is stuck somewhere and I'm supposed to get 70 products from my supplier, but they will come only 2 days late. How do I manage my inventory till then? All that, right? All those started happening. But we have been worried about automating and digitalizing and using of IT technologies in inventory control right from 60s, right? MRP, material requirement planning, that came in 1970s, right? We always used to have BOM. What is BOM? BOM is bill of materials, right? Bill of materials. So bill of material was there in the analog form for a long time. Right. So now we have digitalized the inventory process. Now we can digitalize the MRP process. Right. So capacity planning, aggregate planning, MRP 1, MRP 2. Right. All those started getting on the IT platform. Right. So digitalization of that started happening. Many other things also started happening. For example, CAD. Right. CAD. We know CAD as such a basic thing now. CAD came around the same time, 50s, 60s, right? It had a lot of earlier, it was known by a lot of different names. It was called Engineering Design Automation, EDA, right? EDA, some people started calling it as EDA. In fact, there was something before that also, something was called MDA, Mechanical Design Automation, Engineering Design Automation. It was also there is something called CAGD, Computer Aided Geometric Design, and then it became very generic Computer Aided Design, right? So it is at the center of all the designing functions. The second component, remember, conceptualization was the first component, product design was the second component, right? So it has all the analysis, right? Finite element methods, the failure mode effect analysis, DFMEA as it is called. Lots of commercially available software which can do this CAD for us. Right? CAD is not only simply drawing the product, right? Designing the dimensions and so on. CAD is about all this. CAD is about stress strain analysis, failure analysis, essentially the complete design, right? The complete design of the product. So that started happening using IT way back 1950s, 1960s. We had already started doing that, right? Why is this important? Because once your design is digitalized, once your design is already available in the digital format, you can pass on that digital design to the manufacturing phase so that it becomes easier. They don't have to take those big sheets. Remember, once again, I refer you to old pictures, old movies that we have seen where somebody opens up a big drawing and then say, this is how I design my this is how I make the product. All that is gone now, right? We have a digital design of the product already available, which helps me in manufacturing, right? Specifically, it helps me in manufacturing because it can control CNC, right? Numerical control machines, computer numerical control machines. CNC machines now can be given instructions saying that, well, use this digital design as your input. There is another idea called rapid prototyping. Rapid prototyping started happening because I had original CAD design in the digital format. Okay, so all that started happening because now I had design in the digital format. Okay, then slowly we moved from CAD to computer aided manufacturing, CAE, right? CAE. Why only design part? Why only design part? Why should only design be done? All aspects of engineering, all aspects of product engineering can now be done using IT, can now be done using IT. Once again, we are talking about 1970s. All the CFD, fluid dynamics, multi-body dynamics, MBD, product optimization, right? That started happening using IT. So this was our first phase of digitalization of manufacturing processes. Not strictly manufacturing processes, but manufacturing is not only making the product, manufacturing is also creating the product. This is all creating the product. So you can read about Jason Lemon, and I'm not going to repeat his history here. All kinds of engineering started happening using IT, right? So soon we had a term called CAX, computer aided everything. X is everything, right? Computer aided everything. CAD, CAE. CAE, by the way, uses CAD as its main input. So once the design is ready, now I can do all the kinetics, statics, kinetics, other things, thermodynamics if required, CFD if required. All aspects of designing, all aspects of engineering can be done in the digital format. Okay, that is the argument. Okay, then from CAE we moved to CAM, computer aided manufacturing, 1980s. Computer aided manufacturing did not start as computer aided manufacturing. We used to call it CAM, but originally this M was sometimes called machining. That's how we started, right? So we used to say computer aided machining. Then we started saying computer aided modeling, right? By now, you know, by this we always mean mathematical modeling or physical modeling, not the ramp walk. So CAM sometimes meant computer aided modeling, sometimes it meant computer aided machining. But by 1980s, we had stabilized, and now CAM always means computer aided manufacturing, right? Essentially, it was born in automotive industry, it was born in aviation industry. Rockwell has a huge history of Rockwell Automation. Has a huge history of doing a lot of things in CAM, doing a lot of things in CNC development, right? So essentially, that is when the NC machines started getting implemented widely. CNC machines were used very widely. Numerical control machine, computer numerical control machines. Remember, the very early numerical control machines used to have these punch cards. Punch cards were the instruction cards. So that tells the machine what are the instructions, right? Therefore, the worker doesn't have to keep changing the knobs. once the instruction card, the punch card is punched in, the machine knows what to do, right? And therefore, essentially, that is the way of controlling the machine through IT, right? When I say it was born in automotive industry, there is a big history of in 1960s. Renault is a French manufacturer, French automobile manufacturer. Renault, particularly engineer by the name Perry Beziers. What is his name? Beziers. Perry Beziers. He did a lot of things, right? And that's how initial conceptualization of CAM happened. We have Alex Hammer. Right? Alex Hammer working on turbine blades. Right? We have that case study also. A lot of people started thinking about a lot of manufacturing processes using IT, and that's how we got into this. Right? All the G codes for the CNC machine. Remember. Okay, you probably have not studied this. G codes are the instructions, are the computer instructions. There is an IS standard for it. It is called RS274. RS274 are the standards under which G codes are written. So those, I told you earlier, what is NC machine? NC machine is the punch card which has a list of instructions to the machine. Right? When we had CNC machines, we don't have to have punch card, but there is a specific syntax in terms of G codes. Which is controlled by standard RS274. Now, even that standard, a lot of different countries are using different standards. So, essentially, you can think of G codes as some kind of a programming language for CNC, right? Some kind of a programming language for CNC. CNC need not always be controlled through G codes. There was also something called BNL, right? BCL. Right, BCL, which was developed by MIT, right? What was BCL? Binary cutter language, right? Binary cutter language. So, binary cutter language, which was also some kind of automated, some kind of IT instructions that machines can understand, and they will know what to do on that particular product, right? So, a lot of developments in CAM, which resulted in better efficiency, better performance, better operational flexibility. All kinds of nice things, because now we were doing things more automated way, right? A more automated way. So computer aided manufacturing, as we just saw, essentially is about how to get product manufactured, right, using CNC machines, right? We can write those G codes and essentially machine instructions. The machine has already been decided, the operation has already been decided, and we are just interested in manufacturing based on the design of the product, right? Based on the design of the product. But shouldn't there something be between CAD, which tells us what is the design of the product, and CAM, which is about a particular machine, which tells the machine what to do when the product comes to that machine and says, okay, this is how much you drill, move the drill by this much, this many units, move it in this direction, then move it horizontally this much, drill one more hole, right? Essentially those instructions. Who gets to decide that the product will come to this machine first and some other machine later on, right? So there has to be some IT function that sits between CAD and CAM. So based on the product design, there has to be some code that says that, oh, send the product to this process first. For example, if the product requires drilling, milling, and then turning, right? So should the drilling be done first and then milling and then turning, or should the turning come first and then drilling and then milling? There has to be some solution that tells us that. That is what is CAPP. So CAPP is a link that connects CAD and CAM, right? CAM is essentially for individual machines. But the routing, right? The routing of product to a particular process is done through CAPP. So CAPP is what decides the entire production process flow, right? The production process flow. So product, if the design of product is this, like this, the product should go here first. The product should go to machine 1 and then machine 2 and then machine 3. Now, what is this machine 1? What is this machine 2? What is this machine 3? Right? Machine 1 could be a drill, machine 2 could be a miller, and machine 3 could be a turning machine, right? Or for some other product design, the first machine that the product goes to can be a milling machine, and then could be a drilling machine, can be a turning machine. So depending on the design of the product, what should be the processes that should be carried out? That is done through what are called as route sheets. Route sheets are essentially the routing of the product through various machines available on the shop floor, right? So that is our CAPP. So essentially nicely combines inputs is from the design of the product, output is what machine does it go to, and then CAM will decide once the product goes to that machine, the CAM will decide how to write that instruction, and then write that instruction and essentially get the product manufactured or get the manufacturing process completed on that particular machine. Right, CAM itself, right, we have seen the G codes and the standards, right, various languages. Then came what was called as CIM, Computer Integrated Manufacturing. This was mainly popularized through this book that was written by Harrington in 1975. I always tell my student, I recall reading from this textbook in my undergraduate studies, right? So this was our textbook. For one of the courses, this was our textbook. So to me, this book was the first time we started talking about now what we call as digital manufacturing. This book was the first time when we started talking about something called digital manufacturing. So this is about complete manufacturing, right? The entire production process. So CIM doesn't talk about individual machines, not writing codes for individual machines. It is the entire production process, right? So in fact, it extends all the way back to CAE and CAD, sometimes including all the CAX technologies as components of CIM, right? So this was really the first time when we started talking about end-to-end IT-enabled manufacturing, right? IT-enabled manufacturing. So really the application of ICT to manufacturing was this was the idea proposed by that book, right? Many organizations, many industries have been able to do this completely IT-enabled manufacturing end-to-end, which means that they have achieved CIM completely. Some organizations have done it in bits and parts. Some organizations have not been able to do it, and therefore a lot of things are still manual. But CIM is the place. CIM is the place where we talk about. In fact, CIM is the place where we talk about sensors, right? Real-time inputs coming from sensors, and how does that impact manufacturing? How do we change the routing, right? All that was done long time ago, right? So once again, this is not a new technology. So I have always harped back on that argument. This is CIM clearly is not industry 4.0. It is still industry third revolution, right? Third revolution, not fourth revolution, right? Clearly. So and CIM also spoke about closed loop, which means that feedback mechanism, right? So if something is going wrong, I can go back and correct myself. I can go back and make sure that the repeats are not repeated, the mistakes are not repeated, for the subsequent products. So this is really, CIM is the first place where we talk about full integration of IT in manufacturing. Every step, right? All CAX components, CAF technologies are essentially components of CIM. Okay. So that is very, very brief summary of CIM.